Alrighty, guys. Today we are moving on to lesson number 5. So this lesson that I have opened here is the one that I attached to this email. You can go ahead and pull that up or follow along on a separate sheet of paper. And then I have my calculator pulled up here. You might want to have that just in case. So here we go. This again, lesson number 5, the power of exponential growth. So we haven't had a lot of time to talk about this in class, but if you haven't noticed yet, those arithmetic sequences that we've been talking about are very similar to linear equations, y equals mx plus b. And then the geometric sequences that we've been talking about are called exponential functions. If you remember at the very beginning of the year, we watched a video about the bacteria that was multiplying. So that would be an exponential function or our geometric sequences. So today, that is the name of our lesson. What we're going to do is kind of compare the two together on the first part today. So you can kind of see what that'll look like. So here we go. Two equipment rental companies have different penalty policies for returning a piece of equipment late. Company 1, on day 1, the penalty is $5. On day 2, $10. Day 3, $15. Day 4, $20, so on, increasing by $5 each day. So let's go ahead and fill in company number 1. For the sake of making this easy, I'm not going to put in dollar signs, but please pretend that they are there. So day 1 would be 5, day 2, 10, then 15 and 20, which they told us. Notice that this is increasing by 5 each day, so that would be an arithmetic sequence. Common difference of 5, so we are going to just continue to add 5. So 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. Okay. Company number 2. On day 1, the penalty is 1 penny, so 0.01. And day 2, it is 2 pennies. Day 3, it is 4 pennies. Day 4, it is 8 pennies or 8 cents. And so on, doubling in amount each additional day. So because this is doubling, or if you notice the change here is being multiplied by 2, that makes it a geometric sequence. So if you need your calculator, bust it out. Otherwise, let's go ahead and finish up this pattern here. So if we double 8 cents, it becomes 16 cents, and then 32 cents, and 64, and then $1.28, I think 2.56, 5.12, 10.24, and then 20.48, and then I think 40.96, and that is where I get stuck doing it in my head. 81.92. And then if we multiply that by 2, 163.84. Go ahead and pause me if you need to catch up getting this chart filled in. So I'm looking at the question part now here at Jim Renton. So Jim rented a digger from company number 2 because he thought that it had a better late return policy. The job he was doing with the digger took longer than he expected, but it did not concern him because the late penalty seemed so reasonable. Notice with an exponential or geometric function, it starts off very slowly, almost like a flat line if you were to look at it. And then once we start getting down here, because it is doubling, those numbers are going to grow very rapidly. Notice it doesn't have anything consistent like this. Over here is plus 5. You know exactly what's going to happen, but because this is doubling, it tends to grow at a much more rapid pace. So next part of the question, I'm looking here, second to bottom line. When he returned the digger 15 days late, he was shocked by the penalty fee. What did he pay, and what would he have paid if he had used company 1 instead? So for company 2, that 15-day late policy, I think I would have fainted right on the spot. It looks like he had a charge of $163.84. Had he gone with company number 1, still would have been a pretty hefty late charge, but a little less than half of what he got with company number 2, and he would have paid $75 instead. So if you go ahead and look at page 2 of the document that I sent you, letter A says which company has a greater 15-day late charge. Obviously, that is company number 2. Letter B, describe how the amount of the late charge changes from any given day to the next successive day in both companies 1 and 2. Pause me now to think about that, please. So company 1 again has that +5 pattern, or an arithmetic pattern, also known as a linear pattern. It increases by $5 each day, whereas company number 2 has an exponential pattern or geometric pattern, and it has its value being multiplied by 2 or doubling to the next day. I'm looking at letter C. How much would the late charge have been after 20 days under company number 2? Go ahead and pause me and get that figured out, please. There is a couple different ways that we can do this. So number one, we can go ahead and just keep going on with this little pattern that we have going on here. Let me give myself a couple more lines. So we could say day 16, and we can double these amounts, and then go to day 17, day 18, and keep doubling the amounts until you get to 20, kind of like a recursive rule where you need the last one to get to the next one, sort of thing. With the first company, again, +5, +5, +5. Or what we can do is create an equation for it. We know that company number 1 is an arithmetic sequence because it has a +5 pattern. I'm going to make this bigger. Has a +5 pattern. So what I can do, and I'm going to type this in, but you guys definitely can just write this in. You don't need to worry about getting all fancy with the equations. Oh my, I don't even know what I'm doing here. Okay, so my equation here, I'm going to start off by saying, my computer is being slow now. Okay, let's see. Sorry about that. So it looks like we have a sub n equals, and remember in arithmetic sequence, we first take the first term, and our first term is $5. So $5 plus, and then we use n minus 1 and multiply that by the common difference, which is also 5. We can go ahead and simplify this then and distribute that 5 in. So that would be 5 plus 5n minus 5, which would simply, whoops-a-daisy, which would simply leave us just with 5n. Now, if I want to know how much the late charge would be after 20 days, I can simply plug a 20 in for that n and say 5 times 20 is going to be a $100 charge. So if he rented it with company number 1, 20-day late fee would be $100. Now looking at company number 2, same idea, but, well, same but different. Same idea with writing the equation. We know that this one was being doubled each time, so we're going to classify this as a geometric sequence. So a sub n equals our first term, which was 0.01, and then we're going to multiply that by the common ratio. What's happening each time here? It's doubling, so times 2. And then we're going to put that to the power of n minus 1. Now, again, very similar to what we just did in the last one. If we want to know what it is for the 20th day, I'm going to erase this 16, I'm sorry. For the 20th day, we can just plug a 20 in here. So I'm going to go to my calculator and say 0.01 times 2 to the power of 20 minus 1. Now, this is going to be an absolutely outrageous number because we are taking 2 essentially and putting it to the power of 19. So multiplying 2 by itself 19 times is going to be crazy big. Okay, not as big as I thought, but still big. $5,242.88. Honestly, if somebody told me that was my late fee, I think I might just drop dead right on the spot. $5,000. Are you kidding me? That is nuts. I hope question 1 was okay. I'm going to go ahead and stop the video here, and then we will come back for example number 1.